Alrighty, so we should be live now in a second, and I am going to be continuing with Scala. So we finished off on the domain modeling chapter, which is about traits. We got through traits. We use extends here. Now we were getting into classes. So I guess that's where I will start as soon as I'm sure that the stream is working. And let me see if it is. Our volume sounds a bit better. Okay, so where were we? Let me open my IntelliJ and get my Scala project back up here. So we were practicing some stuff, functions, varargs, right? We made a fake ternary operator yesterday. It was pretty funny. So, okay, so this is pretty similar to what you'd see in Kotlin, right? That looks pretty similar to Kotlin. You have constructors and other class-related things. So that comes here. So we're not quite there yet. We got through enums, right? We got through match expressions. So wait, when you make an enum, are these things classes? Because, all right, let me just do the classic crest size, right? Well, I would say val test equals crest size dot small, right? And then you would say test match case small line small pizza. I guess you would do everything else with underscore, case underscore. Alright, so what's mad at me about? What's the issue here? Oh, of course, it's like this. Cool. So I can't do that. There's no... Alright. I have to write it out completely like that. Are we sure? I thought here it says you don't have to. Oh, but that's because they imported everything. Well, that's a bit weird. Wouldn't it be something like this? Because this is the type, and then what's the issue here? Type small. Okay, this is an object. Crest size. And this is... What exactly is small here? Is it an object or is it it's just a case? That's an interesting choice. Okay, so this isn't really a type. This is like an object or something. All right, interesting enough. I don't exactly understand what's going on here the same way that I do with Kotlin. All right, here, hold on. Let me just edit this real quick. Stream's current bitrate is higher than the recommended bitrate to 500. So I would go to settings, video, nope. All right. To 500 is what they would want. All right, so let me see if that changes things on the stream. It does not, and now I shouldn't get any trouble with that. Let me see if there's anything else in here I can do about the quality being a little lower. Video is currently active. Okay, sure. So this is yeah, I guess the nice thing about doing it like this is that you can do exact equals checks, right? So you can go and say, okay, well, if test equals crest size dot small, well then do some stuff, right? So print line small. Of course. Yeah, of course. So something like this would work, whereas it wouldn't really with classes. So could I just go and make this case class small? So what then would happen there? One is not an object. Ooh, now we're getting weird. So what exactly is happening here? Does it not recognize that this is... You know what? I'll just do this. Is there anything here about case classes? Okay, here we go. Product types is an ADT that only has one shape. Okay, so I think this is answering some of the questions I was confused about. A product type is an algebraic data type that has only one shape. Okay, I kind of get it. A case class has all the functionality of a class, and it also has additional features baked in that make them useful for functional programming. Okay, so this is like data class in Scala. Are public val fields by default, so the fields are immutable, and accessor methods are generated. Okay, unapply method is generated, which lets you use case classes in more ways in match expressions. All right, the copy method, great. Equals hash code, sure, why not? Default toString. Okay, so this is basically exactly like data classes in Kotlin. So we have then a case. Okay, cool. So this looks exactly like Kotlin. Case class person. Val me person. I don't know. I would guess the average would be age. Does this not format like that? Huh. I really don't like that formatting at all. It should just be a one-liner in my opinion. Yeah. Anyway, with that said, case class is a name and an age. Great, great. So then, can I also make this a var? I can, why not? So then, let's do, in the functional programming style, let's do def birthday, right? Okay, now this is some interesting stuff. Sure, just all right. So if I do this, and then I print line me, so this seems fairly straightforward. Oops, I put the, yeah, yep. All good. Now, with that said, you would want to destructure this. So if I wanted to do name age equals me, that should work. Like that. There we go. So you have that nice pattern matching. You can print the name. Can you print multiple things at once? No, you cannot. Which is a bit annoying, but whatever. So you do have that pattern matching. It's very cool. And you could go and match a person. So I can do me match. And then I don't know, man. I really just am not a fan of this. Me match, like, so if it's a person with age, say, 10, no, of course, that wouldn't go there. You just say anything 15. Oh, right, case. Does it force you to have exhaustive? I would guess so. Right, that looks pretty good to me. Can you also do range matching? You cannot. So that's something that is a bit weird. How are you going to pattern match that? Can you do age if age in greater than 8? Okay, so you have this kind of Rust-like thing going on with pattern matching. You can have these filter-like things. That looks pretty good. All right, well, so far looking good, looking interesting. Now, Scala classes, case classes, traits, blah, 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 all contain methods. Okay, so methods look like that. You have def. You don't have to declare methods return types, so you can write those methods like this if you prefer. Yeah, of course. This is how you call those methods. Here's an example of a multi-line method. Like, okay, I'm not sure if I'm a big fan of this. This is not necessarily, like this idea that the last thing is just what's returned. It's a little tricky, right? Could it be that maybe if you did something like this, well, obviously it doesn't know what these are. So, could I do it like this? So if I had a side effect going on and I just wanted to right, great. So if I did want to ignore the return type, I'd have to say, well, okay, so I'm returning a unit. So even if it's not necessarily always going to return the last thing in the function, that's only if you say it will. So I guess in something like this, does it actually create the person? I would assume so. But first of all, are there init blocks? There must be some way to do that. We'll get there eventually. Okay, so something like this. In this example, the timeout parameter has a default value of 5,000. Good. Because a default timeout value is always supplied in method declaration, the method can be called in these two ways. Okay, cool. So you have default parameters, very similar to Kotlin. You can name them. Great. It's particularly, yeah, obviously, because I mean, this is just unreadable. Now we get to extension. The extension keyword declares that you're about to define an extension method. Cool. So then my question is, when you do something like this, how doesn't, okay. Dot make it. So something like that. Can I also just do s.toInt? Right, but that doesn't include the radix. I honestly don't like that they name it option. I think it should be called maybe, and then you would have s.toInt maybe. Like, that just seems more reasonable to me than calling everything option. But whatever. So we have all this, and I don't have to specify that, but it would like me to. Sure, why not? So how do I do this with curly braces? Do I do this? And that way, can I do multiple things now? I can. Whereas with this, it would be awkward. Yeah, it would be awkward. It wouldn't. But I just don't like this because it's not consistent with how it is with like a class, right? Because if you have a class person and you do this, or well, you need val. Like it starts to blur the line between when do you need this, when do you not. So I kind of prefer to just use this all the time, but whatever. All right. Has most features you'd expect. Lambdas, higher order functions, immutable collections. Cool. So this is kind of strange. I don't really, this kind of doesn't look like a function at all. Unless it is. Wait, hold on. If it is, then I'm fine. So is this just, yeah, but then you can't, so if I said then this was an int, function that takes an int and returns, what is the type of this thing? There you go. So now this is a valid function which takes an integer, returns an integer, and I can print that, right? Well, actually that wouldn't make sense. Yeah, that wouldn't make any sense. It's a lambda, right? But I could apply it to like a number, so I could do func1, and that should be 2. Great. So that's fair enough. So this is just this makes it a valid function. When I do say it, I prefer it personally. I find that to be more understandable. But no difference. If you use underscore, that's fine. So that is a real function, which I can just like list 1, 2, 3 dot map func print line mapped, and then right there I should get 2, 3, 2, 4, 6, of course. There's no magic going on here except that this makes it a single parameter function. Cool. Map double. That's nice. Passing lambdas to higher order functions is part of the Scala experience. Yeah, of course. When you work with immutable collections like list vector, not sure about vector, mutable map and set classes. It's important to know that these functions don't mutate the collection they're called on. Instead, they return a new collection with the updated data. As a result, it's also common to chain them. Yep, so you do this, right? In range Scala. How do I check whether something... Well, that's not really satisfying. Whatever. Object. Yeah, object. I mean, I kind of know about objects already, so I should be good here. S equals null or s dot trim dot is empty. Right trim, etc., etc. Because it's a singleton, its methods can be called directly on the object. Okay, cool. So now I'll compare the an object. I already did this yesterday with the with something I was doing. I forgot exactly what it was, but I did use this. This is cool. I understand it. You have well, this is in this case, this is kind of a dumb way to use it, but this is mainly for static methods. I would have liked if they used the word static in here to make it more clear, but whatever. Can also be used to implement traits to create modules. Takes two traits and combines them to create a concrete object. That is interesting. I don't see how this could be ever useful. Well, maybe. But why would they be in traits? This seems like it doesn't really make sense to me yet. Collections. Okay, great. So now we have collections. Range methods. So until is exclusive. To is inclusive. That is really dumb. I don't like that like at all. They really should have just done the Kotlin thing and provided methods. I mean, like it's not that hard. Look. Extension, like they did this anyway, so why not just make it the right thing? Can I name it this? Yeah. So you're telling me it's not supported? There's no way you could do that. Well, in that case, maybe not. Maybe that's a bit... That is quite silly. Okay, so this is already something that you can do in Kotlin, but not in Scala. That's a bit Dumb. Whatever. We'll live with it. Should be okay. Now then, creating lists. To give you a taste of how these work, here's some examples that use the list class, which is an immutable linked list class. So that would explain it. That would explain why you would want to use vector for most things. Right, because a list is not fast. Sure, interesting. Okay, this is dumb. Why is it giving me list.range? If you can do the exact same thing by just turning it into it's a bit dumb. So it seems like I accidentally turned off my camera, which is great. I'll try not to do that again. Okay, list methods, etc. Hopefully these methods all work on other stuff too. But anyway, drop to, drop while, it's less than 25, filter. Okay, so these are all the classic things. Flatten, cool. Map, flat map, okay, all good. What's even in this module? A lot of stuff. Quite a bit of stuff. Where's the vector stuff? I'm not seeing it. A vector is already mutable then. So I can just do That's interesting. I guess not quite there yet. Yeah, I'm not reading all that. I'll pass. Hold left, reduce left, etc. All good. Alles gut. So then Tuples. So I create a tuple that contains an int, a string, and a custom person value. Cool. Once you have a tuple, you can access. Oh, this is how you do it. You don't. Okay. Right. So I was kind of being a bit silly, where I was trying to do t dot underscore one. So in reality, it's t0 is what it is, and that's array-based indexing. So like 0 is the first element. And you can use the extractor approach or pattern matching approach to take the values out. That's cool. Under certain circumstances, you can omit some parameters of method calls that are considered repetitive. It's all about context. These are called context parameters because they are inferred by the compiler from the context surrounding the method call. Okay, what does that mean? Consider a program that sorts a list of addresses by city name and street name. Cool. Sort by method takes a function, returns a value. Cool. In this case, we pass a function that returns a pair containing city name and street name. Note that we only indicate what to compare, but not how to compare the comparison. Okay. Yeah, that's right. I don't see how this could possibly sort stuff. As in, like, how is that going to return a value or anything useful? Note that we only indicate what to compare, but not how to. Okay, yeah. But how does it know? So sort by takes a second parameter. So we only gave it one. Second parameter, a context parameter that is inferred by the compiler. It does not appear in the above example because it's supplied by the compiler. The second parameter implements the how to compare. It's convenient to omit it because we know strings are generally compared using the lexicographical order. However, here this where it gets interesting. It's also possible to pass it explicitly. Well, I mean, what is that? That is interesting. That is something very interesting. Very strange. Well, we will get there eventually, because I don't fully understand the bigger scope of this, or like how does it work when it comes to, you know, other situations. With that said, with that said, let's see what's going on here. So this is array buffer. So that's what you'd want to use for array buffer, and it's just like array list, or is it different? So it's the Scala version of array list, and I guess it would have some other features which the regular array list just doesn't. Capitalize, make string. So this I don't like this function name at all. It should really be just join string or join to string, like it is in Kotlin, or even just join. But whatever. You can create type aliases. Okay, type alias or alias or however you want to pronounce that. Here with package. Okay, I don't know what that is. Uh, package. This is like what module in Rust? I don't know. Well, I don't fully understand this one. I'll skip it. Okay, in the previous stuff, we saw some introductions. So now I do have, by the way, this Scala thing downloaded. Finally got it, and it's I have the REPL now, so I can do like val test equals 4 test line test times, I don't know, big number, another big number, val test equals, can you override this? Nope. There's no shadowing. This should really be a var. Okay, that's not a number. That should work though. Do it again, do it again, again. What's test 3 now? Large number. Cool. I could do it some more times. It should be fast enough. So like big int is nice. I should also try big decimal. Var test 4 equals big decimal 0. Test 4. I gotta remember I can't do that very well. So let's see now, test 4 is should still be a number. Now test 4 divided by equals, now let's see what test 4 is. What are some big decimal methods? Well, how do I actually get it? But that's not helpful. This is super dumb, man. How did Java really think this was a good idea? Anyway. Uh, right, Scala. It's kind of not clear. Oh, clear, Scala. So then what was all this? Price value exact. Double value. So this is what you kind of want to do when you so if I do 1/3. Right, so this is technically infinitely small. Right. But then test so if I do this, test should still be really small, but then Okay, so it loses a bit of accuracy, as you can tell. Hmm. Interesting. Okay. First, look at types. All values have a type, including numerical values and functions. The diagram below illustrates a subset of the type hierarchy. Any is a supertype. Any has a subtype matchable. Yeah, okay. Matchable has any val, any ref. Cool. Cool. These are your vals. These are your... This is also a val. Okay. Makes sense. There's actually exactly one instance of unit which we can refer to as that. So if I do this, T here is unit. That's not a thing. X dot type of val Scala. Reflection, etc., etc. Basic dot get class. Okay, interesting. Seems a bit strange, but whatever. I'm not gonna be that focused on reflection anyway, so I don't care as much. Those are all subtypes of any. Cool. Here's the output of the program. All good. Now, Scala has value types. Those are the value types. Yeah, we talked about this. I mean, that's fairly straightforward, just numbers, booleans, string and chart. Are those also value types? I don't think so. I don't think string is a value type. Really? Those data types and their ranges are... No, it's not a value type, man. That's a reference type, right? Okay, cool typecasting. A real classic. This idea that you are... Wait, why can you cast all along to a float? Huh. Why can you cast that? I don't like that. I don't think that should be allowed. I think it should make you do it explicitly. I mean, like this. And by the way, this shouldn't be the same number. This should be like losing precision a little bit. Yeah. Value types can be cast in the following way, etc., etc. For example, character can be. Um, so characters are 2 bytes in Java or JVM languages in general, which is cool because you can store some more emojis. Not as cool as Rust, but cool enough. You can also cast a reference type to a subtype. So polymorphism, I guess, is what it's trying to say. Nothing is a subtype of all types. Okay, so this is just like Kotlin. Null is a subtype of all reference types. Currently, the usage of null is considered bad practice. It should be used mostly for interop with other JVM languages. Cool. An opt-in compiler changes the status of null to fix the caveats related to its usage. Let's see, what are they talking about? Explicit nulls. Cool. That sounds nice. That sounds useful. It's cool and nice and nice. All right. Whatever you, in this case, just use option, right? Just use option. Is there null pointer optimization for Scala? I mean, surely, right? None. No, but this is just wrong. I don't know what this is talking about personally. So you're telling me I can say, well, abstract sealed class extensor. Okay. Okay, well, this is interesting. Syntax. Uh, what on earth? Why are there so many ways to do the same thing? That's so dumb. Why can you do that in so many different freaking ways? Not a fan. I would rather just take to.map. I prefer that much more uniform, much more clear what's going on. So anyway, are you saying to me that I can go and print possible null? Please say no. Really? Come on. That is a huge design mistake. It really should be like this if you want to be able to use null. I mean, how are you gonna mess that up? That is a big design mistake. That is a very large mistake in my personal opinion. Alright, as we were saying. Uh, SF raw, okay. For pending S. Okay, so I've already seen that. The S string will have access to all variables that are currently in scope. String interpolation will not happen in normal string literals. Right. This we already went through. Okay, I don't know whether I love that. Okay. Finally, all multi-line strings can also be interpolated. Cool. The F interpolator. So it's like printf. Cool. All right, that's fine. I think I'm probably done for today. Nah, hold on. I'll keep reading. Oops. Custom interpolators. Oh, cool. So you're gonna make a point. Mm-hmm. I see. All right, well, that's probably it for today. I'm feeling kind of tired. Um, so I'm probably gonna end stream just about now, and I'll continue with Scala maybe tomorrow, maybe not. Um, yeah, we will have to see. Mhm. All right, so I'll pause here, and we will continue a little bit later.